Hello, today's screencast is going to be about Newton's second law of motion and momentum. We will be starting with Newton's second law of motion. His second law of motion says that the acceleration of an object is dependent on the mass of an object and the force applied to it. Some of you might be saying, oh yeah, I understand that, and some of you might be saying, I have no idea what this could possibly mean. So let's explore it a little bit further. If I have this bowling ball here, how can I change the object's acceleration? One way could be to change the mass. If any of you have ever been bowling before, you know that there are different weights, if you will, of bowling balls that you can choose anywhere from like a 6-pound if you're a smaller child, all the way up to as much as like a 14, 16-pound ball. I usually use somewhere in the middle. But if we change that mass, it will change how the bowling ball rolls down the lane. The other thing that we can do to get the ball to accelerate and move faster down the lane would be to change the force. So we can put more force behind our throw, or we could put less force behind our throw. And in doing that, we can change the acceleration of an object. Now we're going to look at a few practice problems. So acceleration can be solved by dividing the net force by the mass. There will be times where we might want to find the force, which is mass times acceleration, or the mass, which is force divided by acceleration. All of these are connected to each other. They're all based off of our first equation, and then we've used algebra to sort out the others. So let's start with our first problem. It says, calculate the mass of an object with a force of 90 newtons and acceleration of 15 meters per second squared. So since I'm solving for the mass, I need to use this equation over here. M equals F divided by A. So I will start off by taking my force, which is 90 newtons. I will divide by 15 meters per second squared. Okay, and if I think about how many times 15 can go into 90, are we thinking in our heads, hopefully we should get 6, because 15 goes into 30 twice, and then 60 would be 4, and 90 would be 6. We could also check that if we needed to on our calculator. So then we have two options for our units. I had newtons on top divided by meters per second squared, which I can write down. Or since I'm using our international standard units, I could also write it down as 6 kilograms. All right, let's move on to our next problem. The next one is a little bit more detailed. It says compare the acceleration of a semi-truck and a race car. Okay, so these probably don't accelerate at the same rate. We probably know this. If we wanted to buy a car that's going to accelerate the quickest, think about which one you might want to choose. Both have a force of 800 newtons. The mass of the semi-truck is 2,000 kilograms, and the mass of the race car is 1,000. So here we're going to use the same force. We're going to imagine that we're using the same force on them, but we're changing our mass. It says, which accelerates faster? And is this what you would expect? Explain. So we have to look at our equations. And so for here, since we're asked to solve for the acceleration, I'm going to use acceleration equals force divided by mass. I'm going to scroll back down. And so both of them will be, let's see, I'll do my semi-truck first. And I'm going to have a force of 800 divided by 2,000 newtons divided by kilograms. And a force of 800 newtons divided by 1,000 kilograms. And I'm going to see what this gives me. Now, like I said before, you are allowed to use a calculator. So I will use one at this point, so you can kind of see how this would work. So 800, I type it in top to bottom, divided by 2,000. Oops. You gotta make sure you type it in correctly. Try this one more time. There we go. 0.4. And now, what do we think it's going to be if I only have 1,000 kilograms? Is that number going to go up, or is that number going to go down? It went up. So if we think about this in terms of which one's accelerating faster, right? My race car is the winner, right? So just like if I go back to my bowling ball idea, if I have a smaller ball, it's going to be easier to send it faster down the lane. All right, and let's go to our last question here. The last question says, calculate the force required to move a semi-truck if the mass of the truck is 44,000 kilograms and the acceleration rate is 0.12. If I scroll back up, this time I'm asked to solve for force, so I'm going to have to multiply. So mass times acceleration, 44,000 times 0.12. And that answer, if I were to put it into my calculator, is going to give me 5,280. Again, I've used all my standard international units, so since this is force, I could put newtons. If I didn't know that that was the case, then what I could write instead of newtons, so I'm running out of room, I won't write it twice, I'll just write it here. I could put kilograms times meters per second squared. Oh, and up here I didn't put my units, so that would be newtons divided by kilograms, because that's what I did, newtons divided by kilograms. And that is how we solve the different ways of Newton's laws and compare how we can move an object and change its acceleration, right? We can change the mass, we can change the force, and those will change the acceleration. And we can solve for acceleration, for force, or for mass using any three of these interchangeably.